Check if the sentence is Pangram. A pangram is a sentence where every letter of the English alphabet appears at least once. So in example 1, we have the sentence, the quick brown fox jumps over the lazy dog. And we return true because every single character in the English alphabet, all 26 of them, appear in this one string. So we return true. In example 2, we have LeetCode. Obviously, there's just a few characters, not the entire English alphabet. And so we return false. Now, the first way I thought about solving this was to create a set. In Java, sets are a data structure that do not allow duplicates or do not add duplicates. And the idea is every time we pass by a character, we add it to the set. And even if it appears once again, the set doesn't add it. And so by the end, we're going to have a set of exactly 26 characters. And that's what we need to check. If it is 26 characters, then we return true. Otherwise, we return false. But the problem with this approach is that it's not very efficient and there is a faster way to solve it. So the idea is we're going to create a Boolean array of size 26, 26 being the number of characters in the English alphabet. Initially, Java will initialize that array, if we don't set any values to it, to have 26 elements, all of which are false. And what we're going to do is every time we pass by a character, we're going to set the index of that character in the English alphabet in our array to be true. And what that means is obviously in the English alphabet, A is the very first character, so it has a position of 0. And if we pass by an A in our string, then we're going to replace in our Boolean array the element at position 0, which is, like I said, initially false. They're all false. We're going to set it to true. And we're going to do that for every other character. Another quick example, if we pass by a Z in our string sentence, then we need to replace the 25th element in our Boolean array to be true. And we're going to do that for, like I said, the entire string. And meanwhile, while we set all these values to true, in the background, we're going to have an int variable called counter, or unique counter rather, that will increment every time we have a unique value or a unique character. And in the end, we're going to check if our unique character is equal to 26. And if that's the case, then we need to return true. So let's begin coding now. First, we need that Boolean array that I was talking about. We can call it scene equals to new Boolean. And we give it a size of 26. And we need that int unique counter, which is equal to 0 initially. Now we're going to loop through the characters in our string sentence. So for every character C and sentence.toCharacter array. Now this is how we're going to calculate the relative position in the English alphabet of the character that we're on. So int index is going to be equal to C, which is the current character that we're on, minus A. So what's going to happen here is we have these two characters, C and A, and because we're performing an arithmetic calculation, this is automatically by Java going to be converted into an int. And you might be asking, what's C minus A as an integer? Every character in Java has an equivalent ASCII value. A has or lowercase a has an ASCII value of 97. And so B would have an ASCII value of 98, C would be 99, so on and so forth. So when we do C, the character that we're on, minus A, let's say we're on T. T has an ASCII value of 116 if I'm not mistaken. We're going to do 116 minus 97, and that value is what we're going to store as true in our Boolean array at that index. So at index 116 minus 97, we're going to store that element as true. So let's go ahead and do that. If scene at index is false, then what we're going to do is we're going to set scene at index to be equal to true, and we're going to increment our unique counter. So once we perform C minus A, we're going to go to that index in our Boolean array. We're going to check if it's false. That means we haven't seen this character already. Then we're going to set it to true, and we're going to increment our counter. And so if that character appears again, we're going to skip this if statement entirely, and we're not going to increment our unique counter. So at this point, we're going to have a quick check to see if we have a very long sentence, like more than 26 characters. Let's say we have a sentence or a string that's 50 characters in length. Let's say the first 26 characters are the first 26 characters in the English alphabet. We could just return true without checking the entire string, and that's going to make our code run faster. That's just a quick example, but all that to say that if we find 26 unique characters and the sentence or string hasn't been completed yet, like we haven't seen all the characters, then it doesn't really matter, we just return true anyways. So if unique counter is equal to 26, then return true. Otherwise, if we leave this for loop and we checked every single character in our sentence, then what we're going to do is we're going to return unique counter equal to 26. Now this will return true if unique counter is equal to 26 and false otherwise. So let's submit our code and see if it works. I had a typo, I put a column instead of a semicolon, and there we go. So that was the check if the sentence is Pangram problem on LeetCode. I hope you found that video helpful, and thanks for watching.